In this section, we'll be focusing on Cisco Express Forwarding method of switching the packets. Now, what is exactly CEF? As the name itself, it says Cisco Express Forwarding means it's a Cisco proprietary method of forwarding the packets. Now, normally, if you take an example, whenever any packet, let's say there is a network called 192.168.1.network, want to communicate with some other network, let's say 192.168.2.network. Now, whenever this is my source address and this is my destination address, so by default, whenever a PC realizes that the destination is on a different subnet, it's going to forward the packet to the gateway. Now, the router's job is to find the destination network ID. So it is going to verify the routing table. It says show IP route, and it will ensure that there is a destination network ID present in the routing table. And based on that, if it is present, then it will see what is the next hop address. And based on that next hop address, again, it is going to forward via specific exit interface, and then finally it is going to forward the packet. This is our traditional layer 3 lookup, which generally happens in our routers, or if you are doing any routing process, this is the default process. Now, this CEF is something an advance to this process. So CEF is going to ensure that this process can happen much faster than a default process. Let's try to see what are the different types of methods first before we get into the CEF concept. Now, before CEF, we have some two initial methods which was generally used to forward your packets. The first one is process switching. Now, in case of process switching, whenever any packet enters the router, so router is going to do some layer 3 lookup, which is more like a software based. It's going to check the destination network ID, and then it is going to check the next hop IP address, and then it will see what is the exit interface for that next hop IP address, and then finally it is going to forward the packet. Now, similar way, if any other packet comes, again the same process happens one more time. So which means every time whenever any packet comes, even if it is for the same destination, so it is still going to do the lookup. That is something what happens in case of process switching. It requires a CPU. The router CPU has to be personally involved in each and every forwarding decision. So which means in each and every packet entering the router, it is going to do the layer 3 lookup and forward the packet. Now, in this way, it is going to add some more overhead on the router, or a multi-layer switches, we can say. So whatever routing process. Now, then we have something called fast switching method. Now, in case of fast switching method, what it is going to do is it is going to do the same job what generally process switching is going to do. Like whenever any packet comes, it is going to see the destination network ID, and then see the next hop IP address, and then what is the exit interface, and then forward the packet. And after that, it is going to cache this information in the router cache. It's going to maintain that information in the cache, so that if any other user want to go for the same destination, probably it doesn't need to do the routing lookup. It will simply cache this information and forward out of this specific interface. So now in this, the main advantage we get here is we are a little bit reducing the processing utilization here by not looking up each and every time. Whenever a packet comes, it's not going to look up every time. So if the entry is present in the cache, it is going to use that cache information, and in case if there is no entry in that cache, probably it is going to use the normal layer 3 lookup, and it is going to cache again, so that next time for the same destination, if anything comes, again it's going to use that cache. So now these two methods are no more used, we can say. Now Cisco introduced something called a new method, Cisco Express Forwarding method. Now in this method, what is going to happen here is, before a packet comes into your network, before a packet arrives, so it is going to the router is going to maintain one layer 3 routing table. Now this layer 3 routing table is taken in your hardware. So which means this layer 3 table is being downloaded to the hardware, and the processing is done at the hardware level rather than doing at the software level. So which means the processing is not going to happen in your routing table. Instead, it is going to be done on the hardware. So generally, we have something called data plane, control plane. I'll get into that technical terminology. Now that is the main thing here. So when it is doing on the hardware, it can provide wide speed of information. At the same time, this information, whatever is downloaded from the routing table, it is done on the hardware, providing the wide speed. At the same time, it is proactively doing these things, which means before the packet arrives, it is proactively downloading that information and then keeping that information in your hardware so that the entire packet switches through your hardware, and it's going to provide a wide speed performance. So Ceph is something by default enabled in most of the iOS in today's networks. It's going to optimize the router to make it able to forward the packets much faster than normal. So let's try to get into some more in detail about this Ceph, Cisco Express Forwarding. In most of the layer 3 switches, we have layer 3 switches as well as the routers, we can say. So if I specifically say switches, means it also applies for the routers here. Now majorly we have two planes here. We have something called control plane and your data plane. So the control plane, I can say it's more like a software information which is going to build a routing table we call as RIB, routing information based table, and based on that routing table, now Ceph is going to copy this routing table information is carried into your data plane. So now in the data plane you are going to have two tables. We have something called FIB, forwarding information base, and then we have something called adjacency table. So I have that in my next slide here. Now this is your FIB table. Now this is your layer 3 engine, which is your normal control plane, and this is your data plane here. Okay, so now this layer control plane is responsible for building the routing information just like a normal router which is going to do, and based on that this FIB table is going to have each and every destination network ID, and it is built proactively before a packet arrives a router. So which means let's say if I say 192.168.2. network is the destination network ID, and to reach that destination we have an next hop of let's say 10.1.1.1. Now this information is maintained in your FIB table, the layer 3 forwarding engine here, and then it is also going to maintain one more table called adjacency table. In that adjacency table it is going to maintain the exit interface information. So which means whenever any packet arrives for this destination, it's not going to do the lookup again. So the lookup is pre-built. It's going to simply forward the packet out of that exit interface without actually doing the routing lookup, without the software processing going on here, because it is something pre-built already. It's going to forward the exit interface, and this is going to provide a wide speed performance, and it's going to ensure that your packets travel or moves through your layer 3 device much faster than a normal routing generally. Now to verify, I got my 4 routers which I generally use in all my CCNP routing labs. You can see I got 4 routers connected, and all the 4 routers are already pre-configured with your routing protocol. If you verify show IP OSP of neighbor, I did that already. Just for this is a basic thing which I did. And to verify the Ceph, it's by default enabled in most of the iOS. And if you want to verify whether it is enabled or not, when you use show IP Ceph command, you can see this is your forwarding information based table, where you have a specific network entry for specific networks. Let's say if I take an example of any one network, let's say 12.0.0.1, it's going to send via next hop address and what is the exit interface. Now this is something pre-built, and this is done based on your routing table. Again, it is not going to decide any best routes. All the best routes, whatever is given by the routing table, and based on that it is going to maintain that information, so that if any packet comes for these specific destinations, it's going to simply forward the packet out of S1x1 interface. So it's going to make your switching routing process much faster than normal. So if you want to disable, generally not recommended, we can use something called no IP Ceph. This command is going to disable it, and when I disable, if I use show IP Ceph, it simply says Ceph is not running on your router. So if you whenever you see this information, you just need to say IP Ceph command. IP Ceph command again re-enables that. So it's generally not recommended to disable it, but whenever Ceph is enabled, it's going to ensure that your fast switching is something happens automatically. Now even in the switches, layer 3 switches also we have the same kind of process. There's no much difference. Now in your layer 3 switches here, like take an example, I have a source IP A, want to send a packet to P. Now your packet is going between two different VLANs, VLAN 10 to VLAN 20. Now this Ceph is very much useful, especially in your layer 2 network switch environment, where you want to forward the traffic between the two different VLANs. Probably they are on the same LAN segment, but we need to ensure that they need to communicate much faster than a normal routing. That's the reason we have some multi-layer switches involved here, and they send your information at a wide speed, and that is possible because of Ceph. Now it is going to forward the packet. Now the switch is going to maintain that layer 3 information, the software information. This will be forwarded to your layer 2, that is your hardware, with FRB table, and also it is going to maintain some adjacency table, and based on that it is going to see the destination network ID and then forward the packet to that interface. That's how the Ceph is going to work.